introduce Victor Gamov. He's a developer advocate from Confluence. Please round of applause. So if you go into his Twitter, you'll see he's not advocate, he's advocate. So avocado. Yeah, and just to let you know, I haven't met him only yesterday at the gym. We actually met each other at KubeCon, Seattle, and we have both Russian accent, so we kind of see each other. Right? Yes. So we decided to start a podcast which is called Crazy Russians in DevOps. So if you guys are interested, please find us. We're in iTunes now. I mean, Victor is amazing, setting up things and has a nice microphone and everything. If you want to be interviewed, this is the right time to talk to us. We just posted our third podcast, right? Last night? While getting here and preparing this demos and everything. So yeah, we're very productive. So please follow us if you want to hear really strong Russian accent. But we're interviewing really smart people. So please follow us and let us know if you want to be one of the speakers at our podcast. So with that, I want to pass the mic again to Victor and have fun.
Yes, thank you so much. It's been a while. It's been a while since I've been on the stage. Thank you so much for this opportunity to speak again. I guess it was a very well received previous talk, so you decided to bring me again. Jokes aside, yeah. So we actually were doing these podcasts in Russian for a while, and we decided, okay, so why are we talking to Russia? Because no one listens to us. So, Russian folks and KGB guys, because they always listen. So we decided to go, yeah, let's do this. So if you go to this pod.link/CRID, today you'll get the latest episode. A few episodes will come in next weeks. I hope you will enjoy this, and you can always suggest us topics that we talk, or people who we can interview with this KGB style advanced interrogation techniques and the heavy Russian accent, obviously. All right. This is talk, it's a kind of continuation because we established some of the basic foundation. Now, what specifically I like to talk about this is not like how to setting up infrastructures. I want to talk about building apps and how these apps can be scalable, highly available, this, world applications that I build. All right, so, we established the infrastructure. I already taught you how you can deploy your Kubernetes clusters, and essentially this approach that I showed you is essential foundation of the thing that we have. It's a managed service for Apache Kafka called Confluent Cloud, obviously. And we use the same technology. We actually extracted the things that we use to run the production clusters in our cloud, and now the customers can use this. So for this particular case, it really doesn't matter where you run the Kafka, because this is all about apps. So what you do with this data in these apps. You already seen this slide. Yes, I want to say thank you to these awesome people. Again, the Gwen Shapiro, she's amazing. And Matthias J. Sachs, he's one of the engineers here at Confluent. He's also working on Kafka streams, and he is super helpful in Stack Overflow. If you ever end up with Stack Overflow and finding some of the Kafka streams questions, most likely this gentleman will answer this previously, or he will come to help and answer this one. So super helpful people, and they help to build this presentation and some of the ideas that they contributed. All right. So what can we be talking about right now? So I will briefly introduce Kafka streams to you. If you're not a Java developer, you still will enjoy this time because it will give you some of the ideas how you can, what kind of things you can borrow to build your own highly scalable framework. So Kafka Streams is a library, so once it's implemented in one library, I don't see reasons why it cannot be implemented in another libraries. So I will talk about scalability. Obviously, it's highly scalable, hello world applications. I need to talk about scalability and how to scale this hello world application, right? Now, probably not gonna happen, right? So it's not super right audience to talk about this, and some of the recommendation on running this kind of Kafka Streams application. And the cool thing is that Kafka Streams is actually has some of the properties of stateful applications. So that's why it's also relevant to the topic why it's hard and how to make it less hard, right? You can go to this repository, it's a GitHub repository, you can grab all the code there. I'm huge fan of movies. I personally really love movies, watch everything, but not only I like watch movies, but I also love to learn something about movies, about directors, about actors, about the production process, about cameras, about lights, about everything. So I'm kind of like this stuff. So this application that I built, it's another application that's the same one that you see previously. This application allows me to build my own streaming rating system. So I have some movies and I have a stream of ratings. I built like my Rotten Tomatoes, but like a good one. And it uses Kafka, obviously, naturally. And this repository has, I'm trying to establish the same pattern because the application itself, it is quite simple, but it still has some complex aspect that allows me to talk about some of the more advanced topics. So for example, how to serve local state of this application using REST, or how to use alternative languages on JVM, like a Kotlin, for example, and so far so on, like some of the DevOps and operation practices, how to build images out of it, and how to deploy this with Kubernetes, different flavors of this particular thing is targeted to Kubernetes audience. All right. Or if you happen to, run or deploy this application in your organization, maybe you're just supporting some of the Java folks, right? Now, you already learned this part about the Kafka and how the Kafka works with application. Kafka is a foundation. Kafka has ability to save your data, and you will not lose the data because of the replication, because of the way how the Kafka works with the files. Essentially, Kafka has a few aspects of database. It provides you database-like durability guarantees. So it is not like ACID compliant, but also, if you're interested, you can also Google some of the talks from the people talking how to make Kafka ACID compliant, which is an interesting aspect. But essentially, Kafka is a distributed transactional log, right? So what's the log? Essentially, it is a file where you write at the end of the file and read from the beginning of the file. There's no random access, so things going in and going out. So this is why Kafka has, it looks like a queue, but it is not a queue. And you have my permission to correct person who says Kafka is a queue. You can say, Victor told me to correct you, and if you don't want to talk to me, go to talk to him on Twitter. He's a big Russian guy. He probably will have no chance. Kafka has ability, like I said, durability guarantees. Difference between queue and the Kafka topic is that Kafka, you can always replay from beginning. Kafka will not remove message from the topic once you read this message, right? It actually also enables a lot of interesting aspects. Apart from the dealing with this application in the pops up fashion when you're waiting for new events that come into pipe in the Kafka topic, you can use your application to do some interesting stuff. One of the interesting stuff is that things that we saw previously, when we have one message in the queue and we have a listener on the other side and we propagate this through WebSocket to another screen. So we have this integration of two microservices. Another use case is that you're actually performing some of the computation, for example, filtering. You want to remove some of the messages that you don't really care. You do some analysis, you have some predicates that you're applying, and after that, result will be saved in another Kafka topic. So this approach allows you to build the stateless stream processing application. And the Kafka stream has abilities to build stateless stream processing applications. And the difference here is that stateless versus stateful is that when you talk about state, you don't need to know previous result if you want to calculate current step. But with situations like running averages, calculating some aggregations and things like that, you need to know previous result in order to calculate current result. You need to sums up things, you need to add, divide, or whatnot. Now, another component here that allows you to bring data in, because the Kafka streams, it's embedded framework. It works with the Kafka, so it doesn't know anything about external things, like the databases, how you can bring data in. So the Kafka also includes the framework called Kafka Connect that allows you to build connectors, and this is more like a component model. You say, okay, Victor, I want to bring data from Oracle. How we can do that? I can tell you, you go to confluent.io/hub and search for Oracle. And after that, you can install this connector, and the data from Oracle start flowing into Kafka. You can say, Victor, I want to offload this data to Elasticsearch. Once I'm done with performing this, how we can do this? And I can tell you, go to confluent.io/hub and look for Elasticsearch connector. Two types of connector available here is a source connector that allows you to deal with data that comes in, and a sync connector that allows you to deal with data that goes out. So two types of connector, easy. We will be focusing on the processing aspect, but with this diagram, you can actually build like modern streaming pipelines and like a streaming ETL type of thing. This is my application. I apologize if you're not Java. I will explain what is going on here. So this is the Kafka Stream API. This is how it looks like, and everything you can pretty easy to understand because it's more like a functional aspect where you have one individual message that goes through this pipeline. So we start with building a stream from Kafka topic. The stream is abstraction that we build on top of the Kafka topic. It's a Java object that we operating its API that allows us to build this kind of interesting things. So we start by grouping the stream, so we can get the individual message and keys of the individual message. In Kafka, you can have a message that has a key, and we can group by key. So in this case, we get another type of stream called group stream. And the next thing that we can do in terms of grouping, it's another dimension of grouping called window. So Kafka is dealing with the unbounded stream of data. You don't know when it stops. It's not batch. It's not like Hadoop where you have all the data. When you start processing the stuff, you already have this data. You don't have data, and you don't know whether it starts. But sometimes it's good enough to have a result for less 5 minutes. And you have a 5-minute window that will be advanced by 1 second, or 5-second window that will be advanced by 1 second. So in this case, it will create multiple groups of the stream. And after that, we do some aggregation. We want to have a result of the trade calculation that has some value for us. We want to know that what was the price for a particular ticker for last 5 minutes, 5 seconds, and so far so on. And after that, we save the result back to Kafka topic. This is essentially how Kafka Streams application work like. So once this API was implemented, this is how it actually compiles into a thing called topology, or direct acyclic graph. Do we have any like PhDs here?
This happened before.
Huh?
Before we had saved.
Okay, so in this case, I can talk about some smart things, and I will not be booed or throwing the tomato stuff. So there's a thing called direct acyclic graph. How many of you heard about this? Okay, so I'm just shutting up. You know everything. Essentially, direct acyclic graph. It's a topology. It has an end. It has a beginning. It has an end, and it doesn't have a cycle. That's it. No need to have PhD in graph theory. But it just the IT people just want to make things sound more cooler than it is. But essentially, direct acyclic graph is the way how you describe pretty much every computational pipeline these days, right? So the way how it works, it compiles this Java API into this low-level processor API, and each individual node of this particular graph will represent this processor. There's the source node, sync node, and the processor node. And remember when I was talking about stateless stream processing, when you just need to do transformation, or you just need to do filter, so in this case you don't need to have a state. You don't need to remember what happens before. So in this case, a mapping function, map values function, it is something that you do and it doesn't require state. Aggregation, in another hand, requires you state, because you need to remember what happened before, because you're calculating this running overage within 5 second window, right? So the way how it works, for this stateful operation, it creates internal state store per partition. All right. So this is essentially how all Kafka Streams application look like. All right. So how to scale Kafka Streams application? You must be wondering why hell we have these National Geographic pictures here. But I found this particular picture is actually a very good demonstration of fundamental aspect of Kafka. It's called consumer group. So imagine you have a mommy bird and you have 1 to 3 baby birds that's sitting inside a nest. And every time when they wants to eat, mommy bird feed them with the worms. Imagine that this, the baby birds, they will be consuming Kafka topic. And Kafka topic is sharded or split into partitions. So partition is the unit of scalability inside the Kafka. If mommy bird has 10 worms, meaning that there's 10 partitions, and these 10 partitions will be split evenly across these consumers in the consumer group. So mommy bird in this case, it's the component that runs inside the Kafka cluster called consumer group coordinator. Consumer group coordinator is responsible for assigning partitions for these baby birds. So same way as the mommy bird is feeding them with the worms. In this case, it is consumers, and our nest, in this case, it's a consumer group. So what happens if the new baby bird will hatch? So mommy bird will stop consumption, will redistribute this partition, and after that will continue consumption. So this is how you scale your application in order to read this. Number of partitions will define how many consumers you can have. So what's your scalability number for consumption? All right. So what's going to happen if one of the baby birds will fall out of the nest? In the same case, mommy bird will stop consumption and redistribute partition with the restings, and the consumption will continue. So now, when we pass that, we already have this aspect with the with Kafka Streams application. We have an input topic. Input topic in this case will have 4 partitions. For each partition, Kafka Streams will create 4 tasks. So in this case, task is not the threads. Task here is more like an abstraction that Kafka Streams introduced in order to describe this like a concurrent computation. There is some a relation between tasks and the partitions, but in this particular case, it really doesn't matter. Task will execute one topic inside one partition. So in this case, this is the orange dots that we see on the previous slides. In this case, we have one of the nodes that will have state store. As you can see, it will create a state store for each individual task, meaning that per partition there will be created state store. And it's important, I will explain in next slide. So this is how we scale, this is how we increase computation. This is how it works like. How we're scaling this? We start one application, one instance, and this instance will contain a number of tasks that will be equal number of partitions in our topic. In this particular case, 4. We start this, local storage will be created. Now we're starting another application. We want to increase number of computational nodes. So the task will be created in the node 2. But in this case here, you can say, Victor, you still have some artifacts. Have you forgot to move your states from here to here? Which is actually not. And this is why I want to focus on the scale up for now. And after that, we're going to be talking what we're going to be doing with the rest of this stuff. All right. So how we can scale, we can increase more. Can we run more than 4 applications? Who can tell me? No. We can. But the application number 5 will do nothing. So in this case, it will join consumer group, but there will be no partition to consume. So in this case, it really doesn't matter. So in this case, when you're planning how you scale your application, you need to know what the number of partitions in your application. It is important from perspective of ordering and how the messages will be served. Kafka provides you order within partition, meaning that by key, how the messages arrive in this partition, the same way they will be processed. There's no global order in Kafka unless you have a topic with one partition. But in this case, scalability will be meh. All right, so this is how we scale this. This is how we scale this. This is how application runs and performs. Now, how we can deal with the fault tolerance? One of the nodes will go down. Happens every time. We're running this in a cloud native environment, right? So we don't know where we're running, and we don't know when the pod will be rescheduled, so far so on. One of the nodes go down. the coordinator, the application will redistribute the stacks back to the rest application. And this is where the previous state storage would be handy, is that we didn't remove it. And in this case, we need to catch up on the deltas for this state store in order to update. We don't need to replay and reread this and recreate this local state here. How does it work? In Kafka world, I don't know if this word is actually applicable, but I heard that French people, they drink their own champagne. So it's not like, I don't like to talk about dog food, like when they're talking dog food, we eat our own dog food. So the French people say they drink their own champagne. Is it true or not? No one says that, Victor. I don't know where you get this. This is your weird Russian humor. Essentially, yeah, this is like how we drink our own champagne, how we drink our own food. Kafka Streams uses Kafka not only to read data and write data, but also uses Kafka for fault-tolerant support. So this local state store also replicated through Kafka, and the state store always will be replicated if you specify this configuration parameter called log, enable logging. So in this case, if one of the nodes will go down, so that's how it works. There's a special topic called change log topic that also will have the same number of partitions that our input partition for our application. So in this case, our state stores will be replicated through Kafka, and this is how they end up in another application, right? So it is a very powerful concept where you don't really care about your state and how you will make sure that this local state will stay the way it is. There's some applications in terms of what's the recovery time and how the application will recover from the failures and how long it will take. It really depends on changelog topic, and it really depends on how fast of the size of the state. And because it's a low compacted topic, meaning that it only stores latest and greatest value. It doesn't store whole history. But between it actually stores latest and greatest value and whole history, there is some time gap where it's called, so it doesn't do compaction as it goes. Compaction performed in the fashion of the small process that runs in the background that runs this compaction thing. All right? So obviously, if your application has a large state, it takes longer to recover and takes longer to restore. All right, so for the Kafka streams, there's two options how we can run this in Kubernetes. The two things, obviously, run this as a deployment and then everything will work fine. Why? Because we already have Kafka, and Kafka streams knows how to replicate state between applications, right? Because you don't want to use the stateful sets for some reason. You can use it, but stateful sets make things faster. So this local state, this small cylinder that has on each individual instance would be local. In order to your application start faster, it's much easier to restart from local state and after that catch up with some delta from Kafka, rather than restoring full state if you have a large state. If you're doing a lot of stream processing where you don't really care about state, you do filtering, you do mapping applications, you don't really care about state. So you don't really need to have extra resources to support that. So in this case, you can do scale out and scale back anyway. And also, there's some chances that you don't trust your storage admin, so you don't want to take chances, but you trust your Kafka deployment, right? Because you're running this somewhere, I don't know, in cloud. All right, so let me show you how it looks like. Some of the recommendations. I recommend to use the stateful sets because they will make things faster. Next thing is that using the anti-affinity rule in this case allows you to, when you place these applications in the same node, if this node will fail, you will lose not only one pod of your Kafka Streams application, but you lose multiple because they will be collocated and so far and so on. Even though state is still replicated through Kafka, you still will have some troubles. This application can start in parallel. So this is why Kafka Streams actually has an internal mechanism to perform readiness of the application. You don't need to rely on Kubernetes aspects of things because internally the framework knows when it's ready. Again, through the replicated state through the Kafka. Okay, let's see some demos. All right. I always feel like a musician. we have this very nice light here, and I have my piano here, and I will sing you a small song called Rocket Man. Anyway, so what do we have here? So I have this small cluster that I have my topics. So data goes through from two topics. One topic has raw ratings, one topic has some rated movies. And in this case, I want to join them and get some of the results. So first of all, let me do kube control. And I need to do deployment. There's a different one. Deployment. A lot of things here. Movie ratings deployment. So it's a simple deployment. It will bring my application to my Kubernetes cluster where I run the get pods. This is one pod that's running this application. Everything is good. Application is up and running. Now I can do populate with some data. I'm going to data. Actually, I'm probably and I'm putting some data in cloud movies. So I'm populating some of the raw movies where I am, because I'm in the wrong directory. Always check your directory. And you will go here. I'm populating some data about movies. There's like directors. There is actually why I'm talking about this, what I can actually show you. Raw movies. I can do inspect. We'll show you some data. We'll go here. Let's do it once again. The reason why I'm doing this once again, because the way how the Kafka works and the way all these things with the streaming, you need to observe a stream the way how in the moment when the stream actually comes in. So this is why data. This is what comes in. It's just a simple enterprise-friendly format. It's a pipe separated or like there's columns separated. And another thing is that I also populate. I will just generate some raw movies. And raw ratings, Gradle ratings. Yep. So I have this small generator that just pumps data in and emulates that the people go in and put the ratings when the new hot movie comes into play. It also generates, like, people have opinions about movies. So let's see how this data look like. So this data comes into here. Data goes in. True. No messages, probably because it's going to space. From space going to cloud. And this is how our rating look like. So this is something that we're putting in our topic. Now my application already started to do something things, and when I'll do. We'll do consume, and why am I doing this? I actually can show you consuming from here. So I will go topic, and there is a rated movies topic that will have all information that I already have. So my application is running, so I'm performing some of the computation, and my movies looks like this. This is binary format. In this case, I'm using this things called schema registry that reads the data from format that was not contain any schema, and I want to have this schema because I'm interested to save this data back to somewhere. Consume, and this how it look like. The cloud consume. Anyway, like I forgot the actual command. But the data is there. Now the cool thing is that I can always go and do things like edit deployment. This is how I scale my apps, and what I go here and it says replica 1, I go here and do replica 2. So in this case, I will scale my application performance and my another container was created. And because I'm using this deployment here, I don't have any state, and it's quite fast to start application. Now, application itself will try to read, let me do log. Who can help me with what I'm doing this wrong, because the extra one, yeah. I don't have this, I have multiple application right here. Have multiple application, not available, pod streaming, different pods. Anyway, yeah, so now I'm running my application successfully consuming things. There's some, you see there's 2 consumers here, because I started 2 applications, in this case 2 consumers joined the same consumer group. I have 16 topics, so I can essentially scale my app by 16. Let me do that. Like, why I cannot use my all resources? And I'll do 16, right? Do you think this will be successfully executed, things like that? Not really, right? And the reason for that, who can give me a hint? Any Kubernetes solutions architects who can say like why all these pods now pending?
No more resources.
Exactly. So I didn't show you your deployment, and for deployment I'm using this affinity, anti-affinity. So in this case, each individual instance of application will land on each individual pod, and because I am a cheap bastard, number of nodes, I only have 3 here in my Kubernetes cluster. One of the things that I can do is just go here, there, and do resize, or I'll just stop doing these stupid things and get back to the point where I can run just enough. It's easy to scale and easy to use this kind of approach, but if you can, it's not necessarily you should, right? So another option is to use not the deployment, but just use stateful set. It's just relatively straightforward. You just have a sub-storage where this Kafka Streams application puts all these databases, in this particular case, this RocksDB instance, and after that, Kubernetes will be responsible for sharing your state. So this is another thing that you can do with this application. All right, so it's great that the framework supports all the things that that you need in terms of scalability, but when you need to think about scalability in an environment like cloud-native environment, like a Kubernetes, you need to also consider some of the things that framework can do, and that your underlying infrastructure can support. Kubernetes makes things much more easier to do with when you need to scale this application. But some of the things that you need to think about this is always, it's a stateful application, how you will migrate the state. Again, Kubernetes meets us halfway, and the Kafka Streams meets us another way, because Kafka Streams already provide these ways how you can replicate the state. And stateful sets is awesome. I use stateful sets, and it's pretty cool. So essentially, that's it from perspective of Kafka. Now, from today, you know a lot of things: how to run Kafka, how to run stream processing application in Kafka. If you have some questions about this, I always at your service at the community Slack for Kafka and the Kubernetes here at the Confluent, and always there's some of the links that you can use to learn more. And as always, have a nice day, and join me in Twitter and ask me if you have any questions.
Present from CLCF Store is really great at the project, so is it good enough? Okay. Yeah. So Victor, thanks a lot. I'm inviting Victor again in September for GDevFest. So if you have a chance to show up, and you'll talk about you want to talk about how to run. You guys have some announcement around Google Cloud running stuff. So we might bring you again, and you can meet Victor again. So a round of applause again. Thank you so much.